Hey guys, welcome back to another video from the channel Learn from Basics. This is Joe here, and this is the first video on the series on this channel where we use OpenCV, an open source computer vision library, and Python in order to make a lot of cool programs that work in real world, work in real time, and work on CPU that track your hand and do a lot of cool stuff. Now, I uploaded a trailer that shows you all of the projects we'll be doing, and some more will be coming up. But for now, these are all the projects we'll be doing, so check that out if you haven't. Now, in the demo, you probably saw how our hand tracking works. Isn't that really cool? And another cool thing you should know is that you don't need a fancy computer or a fancy GPU in order to run this program this fast. In fact, I'm doing all of this on a laptop. And the reason it runs so good is because this program actually runs on CPU and runs at about 33 frames per second. Yes, isn't that just amazing? Now, before we get started with the programming, I think it would help you to know how this works and the logic behind it. So, before we start, let's talk about the theory. So guys, now that we know what we're doing, what I want to tell you is the basic bare bone knowledge on how this process works, what algorithms it uses, and how it works. Now, I'm not gonna dive that deep into how this works, but all I'm going to say is this basically uses the KNN model, and there's more detail about that in the MediaPipe website, and they wrote a blog about how this works, so I would recommend checking that out. I'll have a link down to that in the description, so you can go and read it. But it's not required, because we're gonna dive into the basics now. Now, one thing I'd like to mention is MediaPipe is the amazing company that came up with this amazing module. And MediaPipe is basically a Google managed company that invents machine learning solutions that run on CPU and run at faster than 30 frames per second. So how cool is that? So it's basically real time. And they have other cool packages like, hand detection, body pose detection, and many other cool things that we'll be diving into. So don't forget to subscribe. Now that we have that out of the way, let's move on to the process on how it detects the hand. Now, I'm not going to tell you how the algorithm works or what kind of code they might have used in the algorithm. I'm just going to tell you the key processes that the algorithm takes in order to make the whole hand appear. So if you want to get more detailed, as I said, I would recommend reading that article. So first of all, it detects the palm or the lowest point of your hand on your hand on the screen. And again, you have to pass in an RGB image in order for this to work. But after the MediaPipe module detects the hand, and should I tell you, this will be very, very, very accurate, because not only does it have a very good AI that predicts how your hand fingers might be positioned even though it can't see it, and the people at the MediaPipe company have annotated almost 30,000 real-world images in order to make this module reality. So I'm pretty confident it'll work, and so should you be. So now let's basically talk about the next step. After it detects the lowest point on your hand or your palm, or like the joint that connects your arm and your hand, it uses another algorithm to detect your palm. And even though it might not look like this, it'll basically draw a bounding box around your palm. And then, now that it knows where your palm is, it finds these key points, the knuckles, and then your whole finger. Now, yes, the process is way more complicated, and I oversimplified this by a lot, but these are the key steps you'll note just so you'll understand the process better. And another thing to note is that, the MediaPipe library also returns 21 key points on your hand with an array or a list of 21 key points, with each item in the list being a list that has four values. The ID of the hand. Now you might be wondering, what do you mean the ID? Well, I'll tell you that in a second. The X position, the Y position, and believe this, also the Z position. So it can also predict depth. And we'll also be doing a cool project with that. So, as you can see, the MediaPipe module produces 21 key points on your hand, and each one point on your hand has an ID. So it basically takes each point on your hand and it has an ID, right? So you can call and get the location of each point on your hand by calling it by its ID. So that's basically why what I was talking about ID. So for example, the tips are 4, 8, 12, 16. The inner joints are 1, 2, 3, 6, 5, 6, 7, 9, 10, 11, 13, 14, 15, 17, 18, 19. So those are basically it. And yeah, so all I want you to know is this is the model of how it should look like. So now that we know the logic behind our program, how about we start coding? So without any further ado, let's head right into PyCharm. So guys, as you can see, I have a PyCharm project opened, and I named it the hand. But again, you can name this anything you want. And remember, we'll be making a module out of this in our next video in order to make using this code a whole lot easier. Now, the first thing we're going to do is we're going to start importing some libraries because, well, we need the MediaPipe library in order for this to work. So what we can do is we can go to File, Settings, and I'm using PyCharm, the text editor we always use to make OpenCV and Python projects. But if you don't have PyCharm and you use another software to write your code, you should be good saying pip install OpenCV Python and also typing pip install MediaPipe. Now, for the people who are using PyCharm, there's an easier way to do this. Go to File, Settings, and then you can simply click on the plus button and simply say OpenCV Python. OpenCV Python. So that's a dash over there. As you can see, OpenCV Python is right over here. And so we're going to install that package. Now this might take a while, and then we'll also install the MediaPipe package. MediaPipe. So let's install that. So as you can see, these aren't that big of modules. They're pretty small, so you should be able to download them in no time. Now that we have the main modules downloaded, let's dive into the main code. So the first thing we're going to do is we're going to import these modules. We can say import CV2, the computer vision module, and import MediaPipe as MP because, well, MediaPipe is just too long to type, and we'll be typing this name many times. So why not just make it short and sweet? So the first thing we'll do is we'll write our bare minimum code that's going to basically allow us to stream live video from our webcam. So we can say you should know this code if you've been doing OpenCV for a long time, but if you don't, that's okay. Video capture 0, that gets us videos from our webcam. And remember, if this does not work, then be sure to if this does not work, make sure that you basically, all I want you to do is I want you to use 1, 2, or 3, because if you this problem occurs to people who have an external webcam. So 0 is for the internal webcam. So you can use another number that will basically activate your external webcam. Then we say while true, success frame is equal to vid.read. And then the next thing we do is we basically show the image, cv2.imshow. We say, let's say video, and then we can show the frame, and then we can say wait key of 0, actually of 1. And let's actually make our frame a little bit bigger because a bigger frame is better to work with. So you can say vid.set 3 to 960 pixels. Now, if I run this program, you should be able to see me. So, as you can see, OpenCV does take some time to run. But as you can see, it detects me pretty well. So that's good. So as you can see, later on, it should be able to detect my hand wherever I move it and however I put it. So now that we have that, let's move on to the next part of our program, which is basically, well, doing the whole process. Now, before we do anything, guys, one important thing that you have to remember is the OpenCV program or the OpenCV module only process, and I mean not the OpenCV module, but the MediaPipe module can only process images that are in the RGB color spectrum. And one thing that you need to know about OpenCV is defaultly the color spectrum of an image is BGR. So we will convert from RGB to BGR. I mean BGR to RGB because that's the this is the color scheme that MediaPipe works with. So we can say RGB frame is going to be equal to cv2.convertColor. Our source is the frame, and this will be cv2.color BGR to RGB. So this convert color module can basically be used to convert it from one color type to another, like BGR to gray, BGR to HSV, hue, saturation, and a value, and many other things. Now, if you don't know any of this, then be sure to check my OpenCV for Beginners guide or course, because you'll need to know these basic OpenCV functions before you move on, like the bare minimum. Now that we have that done, let's take a look at the other frame, RGB video. Now, one thing that you'll notice is whenever I show this frame, you'll see that, well, the image doesn't look quite right. The image is quite distorted. So as you can see it's not quite right, and that's because we're converting from RGB to BGR. So you can see my shirt is blue on the original image, but on the new image it's orange, and you can see my face is blue, the background is blue, and the window is kind of yellow. So don't worry about that. This is just the kind of frame that, well, MediaPipe likes to work with. Now that we have that done, I'm going to comment this because we won't need this. Now the next thing we're going to do, guys, is we are going to send our RGB frame to MediaPipe, because that's all we need to do in order to process our code. So we need a variable to store all of the values in, so we can say result equal to hand. So actually, before we do that, what we have to do is we have to also declare the MediaPipe library, because, well, the MediaPipe library is quite big, and the MediaPipe library actually has many modules, like the face detection module and the body pose detection module. So what we'll be doing is we want to basically write some variables that declare paths in the MediaPipe module that basically take us where we want, which is the hand module. So first of all, we're going to say MP hands or MediaPipe hands is going to be equal to MP dot solutions dot hands. And you want to be, so make sure you don't do this. Now the next thing we are going to do is in the .hands library, we want to further go through and we want to basically go into the empty.hands module. So in order to do that, we can say hands equal to empty.hands. And now inside the empty.hands library or a module, you can actually give in some input values. Now let's see what those input values are, because they're quite important for later on videos. Now as you can see, you can input 4 values. The static image mode, now we'll talk about that later. We'll talk about later after we discuss these. The max number of hands. So this is quite self-explanatory. It basically declares how many hands at max can be detected using the MediaPipe library. So the more hands, the slower it's going to be, the less hands, the faster. But that's really not such a big deal. So you can normally put it at 2 hands or normally put it at 1 hand. But yeah, it's not that big of a deal. The minimum detection confidence is 0.5. So the minimum detection is 0.5, which means the MediaPipe library has to be at least 50% confident to detect or declare an object as a hand. In the minimum tracking confidence, in order to know that, we need to know what static image mode is. Now, static image mode is an algorithm in the OpenCV module. So what it basically does is, instead of searching for a hand in one image, the static image mode algorithm basically searches for a hand in every frame. So it applies all of the algorithms to find a hand in every frame, which is time taking. So another algorithm that's used in the media pipe library is basically it detects the hand in one frame, and after it detects the hand, it basically tracks that hand to wherever it moves, and it starts to detect the hand again after it lost tracking that hand. So obviously the tracking hand method is way more efficient and faster than the static mode image mode algorithm. So that's why we set it to false over here. But again, you can set it to true, but I don't recommend it. And the minimum tracking confidence, again, it's just how confident the media pipe library has to be. That this is the right hand it's tracking in order for it to declare it as the hand. Now that we have the 4 inputs done, let's change the 4 inputs a bit. So first of all, I'm going to set static image mode as normally, but we're going to say max hands, and max number of hands is going to be 1. And I also want to say minimum detection confidence is 0.7, and the minimum track confidence is going to be 0.5, however, or 0.6. Now that we declared both of those or paths into the media pipe library, what we can do is we can pass our RGB frame into the mphance.hands module, so it processes everything. So there's actually a certain function in the mphance.hands module that processes our image. So first of all, we're going to create a variable or a list that stores all of the data the function returns, and we can say hands.process, and then we simply have to give it the image, RGB frame. Now let us run our program because we're basically done. So it should be able to track our hand right now. So as you can see, that's quite disappointing. It can't track our hand or anything. The image is just where we started. But did you know that the program is actually tracking the hand? The reason you can't see anything on the image, you can't see a skeleton of your hand on the image, is actually because, well, you didn't write any programs to draw all of the hands on your screen. Because in order to draw all of the hands on the screen, you have to go into the results list and get the X and Y position of each and every location, every one of the 21 points, and draw them down onto the screen or onto the frame. So first of all, let's see how our result is formatted. So the result, we know the result is a list, but is each object in the list another list, or is it just a number? Let's check that out real quick, right? Shall we? We could say print result, and now we can run our program. And we're not going to focus on the image, instead we're going to focus down here. Now as you can see, there's nothing printed. It just is class mediapipe.python.solution-based.solution output. So what that basically means is that this list is in a different format than what Python is used to. So instead of giving us the list itself, it is giving us the class. So what we have to do is we have to write some for loop to extract that data, and we can actually use that data later on. So right now, guys, let's write some coding in order to extract data from the result list and use it for our own benefits. So the first thing we want to do is we want to check if there are any hands in the frame at all. So in order to do that, we can say if result.multi-hand landmarks. So multi-hand landmark multi-hand landmarks. Be sure you have everything of that right. If result.multi-hand landmark, then print hand found. So as you can see, it's giving us an error sign. So let's check that real quick. Result.multi-hand landmarks. So I think that should work. Let's try this out real quick, shall we? So as you can see, there's nothing, but let's focus on this. So as you can see, when I put my hand in, it says hand found. As you can see, it says hand found, but the second I take it out, the hand is out of the frame, and hence it says it stops. Now I can bring my hand back in the frame, and it continues. So as you guys can see, stop, in, out, out. So we know that our program is working, but because it can detect when our hand is inside the frame and when it's not in the frame. So now that we have that, we know this part is working. So now what we can do is the next thing we're going to do, guys, is we're going to loop through. So as I said, the media pipe library can detect 2 hands, right? In fact, that's what I'm going to do. I'm going to make the max number of hands 2. So obviously, the 2 hands are going to be in different locations. Hence, they're going to have different data sets or different lists. So what we want to do is we want to loop through all of the hands in the frame, and we want to we want to loop through the locations of each one of those hands again. So the first thing we're going to do is we're going to loop through each one of the hands using a for loop. So we can say for hand landmarks, because inside each hand is going to be hand landmarks, the locations in, and then the next thing we can do is we can say results dot multi-hand landmark. So we basically get this and we paste it over here. And then let's print hand landmarks. So let's do that real quick. So now, as I said, this program, what it's basically doing is it's taking my 2 hands and it's basically looping through them in order to get the values out of them. Because as I said, there's going to be multiple frames or multiple hands throughout the program. So you want to loop through each hand in the frame in order to get the best result. So as you can see, you're not going to detect it right now, even if I put 2 hands. It's just going to get more confusing, so I'm just going to do 1 hand. And as you can see, inside each landmark class, you can see there are 3 values: the X position, the Y position, and the Z position. And don't worry about the Z position because we're gonna talk about that later. But the first thing is this value looks weird. It's in a class, right? So how about we make this more feasible and just print out the individual ID, the X and Y location, instead of having it in a class, because that's quite confusing, or a dictionary, because that's quite confusing. So what we can do is we can loop through all of the hand landmarks, or the 21 hand landmarks, inside this hand LM variable or list, because that's where we store the locations of each and every one of the 21 points of each hand, right? As you can see, that's what this for loop is doing. So we can loop through these hand landmarks again and get the location of each point. So we can say for, and then remember, it returns an ID and a landmark dictionary. So we can say for ID and landmark in, and we're going to enumerate hand LM because we want to get 2 values out of one list at the same time, right? So that's why we're going to enumerate. And we're going to say enumerate hand LM. And now what we can do is, now as I said, guys, I'm pretty sure that my X location when I put my hand up was not 0.08, because that would be like extremely to the left. And so you might be wondering, well, maybe it was to the left. So actually what I'm going to do is we're going to just write pass over here for now. We're going to add code there later, but since we're just examining, let's not do that. And we're going to uncomment this real quick. So now, as you can see, my hand, oops. Okay, so we have a problem. So our code is not working clearly. Okay, yeah, I see what the problem is, and we'll get back to that problem in a second. But first, let me explain to you the theory. So now, as you can see, we have our program. Now, when I put my hand, you might be wondering, well, yes, it is to the left. But even if I move it completely to the right, and I stop my program, so the latest results should be my location to the right, you can see it barely touched 1. The 0.67 barely touched 1. That means I'm still pretty much at the left location. So you might be wondering, well, why is that happening? Because clearly my landmarks were not at the total left. So the reason this is happening actually is because, well, in order to get the actual value of this X location, you have to multiply X times the width of your frame and Y times the height of your frame. You might be wondering, why does it do that? Well, it's just easier to return these small values instead of returning the actual big values, which just makes the program a bit slow, and for many other reasons. Now that we have that out of the way, let me explain what's wrong inside inside this value. Now, as you can see, what we're doing is we're getting the whole hand lm variable, which is pretty big. As you can see, there are a lot of stuff in the hand lm list. So what we want to do is we don't want to get everything inside the hand lm list. Instead, we just don't want to get the landmark classes. So in order to do that, we can say hand lm dot landmark. Now what this will do, guys, is it will basically get the landmark classes, the classes that all have the name landmark, from the hand lm list. And that's all we want, right? Because we just want the x and y position of our 21 key points. Now, the next thing we want to do is we actually want to, well, now that we have our ID and landmarks, first of all, let's turn these x and y variables or x and y locations into actual coordinate x and y points that we can plot onto our frame. So let's do that real quick. Now, in order to do that, the first thing we want to do is we want to get the height and width of our frame. So we can say height, width, and so we gave this because it's also going to give us this color spectrum, but we don't need that, so we're just going to give a random variable. And then we're going to say frame.shape. Now what we're going to do, guys, is we're going to say the CX location and CY location is going to be integer. And then we're going to say it's going to be landmark dot x. So it's going to be landmark.x. And actually, let's make this lm because we don't want it to be that long. So we can say, instead of landmark.x, let's make it lm.x. And then again, lm.x times the width, because x times width. And then our y position is going to be lm.y times the width. the height, right? And then what we can do is, the next thing we can do is we will also want the ID, right? So as you can see, the ID is automatically going to get captured. So we can print out the ID, the CX, and the CY. But we're not that good at processing numbers because that's just how our brain works. So let's turn these into a visual format and actually plot the points out onto the screen. Now, in order to do that, what we can do is we can draw a circle. So we can say cv2.circle. We want to draw the circle on the frame. And then our x and y location, or the center, is going to be cx, cy. And then our radius, we can give it a radius of 5. Our color, let's make it green. Why not? 255. And then we can make our thickness. cv2.filled. Now that we have that done, be a way to be blown, because you just made your own program that tracks hands in real time. So there you go, voila. It can track 2 hands, other sides. It doesn't matter. So how cool is that? See, no matter how far back I send it, even with this glare of a light back behind me, it can still detect my hand. So I think that's pretty cool. Now, as you can see, no matter how my hand is, it still tracks it, which is really cool. And it tracks it in real time. And you can see I'm moving my hand very fast. It's in very bad angles, but it can still do it. See, this is a very bad angle for an algorithm to detect, but that is detecting really good, especially when you know that it's running on CPU, not GPU. So now that we have that, you might be wondering, well, yeah, this is pretty impressive, especially the dots being drawn on our hand, but it's not like what we saw on the thumbnail, right? On the thumbnail, we saw that there would be lines between these dots, and it would look like there's an actual skeleton of our hand printing onto our hand. And you can see, like, whenever I make a cluster or when I make a fist, it just looks like a cluster of dots. It makes no sense, right? So what we're going to do is we can write a program in order to let's write a quick program in order to draw all of the lines, or draw all of the lines that connect all of the dots. Now, do you actually think we're going to write line by line code that's going to get each and every dot and then gonna draw a line between each and every dot to form a certain pattern. No, that would be absurd. That would take forever. And thankfully, the people at MediaPipe already know that. So what they did is, they actually gave us a function that allows us to draw stuff onto our, that allows us to draw stuff onto the screen. Or draw connections onto our hand and basically make those dots connected. So in order to draw that, we first have to declare another path, or the mpdraw function path in the MediaPipe library in order to do this. So we can say mpdraw is equal to mp.solutions.drawingutils, and then that's basically it. Now the next thing we're going to do, guys, is we're going to come down here and we're going to say mpdraw. So we can say mpdraw, so mpdraw dot, now this is the function we'll be using, mpdraw.draw landmarks. So as you can see, there's also a function that says draw detections, and we'll do that in a quick second. But as you can see, actually not draw detections, we need to draw landmarks function, because the draw detection is used when you do the hand face detection, not the hand detection. Now the first thing you'll need is the image it wants to draw the landmarks on. So we can say frame, then the landmark list. Now, even though we made a list out of this and we neatly got all the X and Y values out of here, MediaPipe doesn't need that. It just needs the raw list, which is hand LM. And then connections, it's asking us if it wants you to connect them, which is a true. So we can say mp hands.draw hand connections. Yeah, hand connections. Now we'll also do some coding next week, or in the next video, that basically allows you to change the color of the drawings, but that is for another video. So as you can see right now, it should be able to draw connections through my hand. So how freaking cool is that? So as you can see, that's pretty cool. And to be honest, this doesn't quite look that good. Like you can see, there are small circles around my thing. Actually, the reason that is because we are drawing circles over here. So let's comment that real quick. And if we do it right now, you can see we have a hand module. So you can see it detects my hand even behind this glare. You can see the light. Even with that, it detects it. No matter how fast I go, it detects it. So it's pretty impressive, especially it runs really fast on CPU, and the program took seconds, you're right. So as you can see, even if I make a fist, it's easy to process the data, and you can see a skeleton of my hand. So I think that's really cool, and it can detect 2 hands, and it can detect up to 100 hands, so you should be pretty good. And in most of our programs, we're just going to take 1 hand. Now that is it for our program, guys. We have successfully drawn stuff onto the screen, but we're not quite done. Now a good programmer not only gets the data and represents it meaningfully, but he also understands how the data works. And he also understands how to use certain data in order to make cool programs and use it for his benefits. So what we're going to do is we are going to basically see how we can use this, for loop in order to collect the points of our hands and basically do some cool things with them. And we'll do cooler projects later on. Now, before I show you some cool things we'll do, especially one thing, we're going to be doing one thing that's basically going to demonstrate how to use these dots or how to use these points. But before I do it, I want you to do it. Now, here are the 3 tasks we'll be doing. Task number 1, I want a blue dot to be on the tip of the, I want a blue dot to be present on the tip of the index finger and a blue dot to be present on the tip of the thumb finger. And then I also want a connection line going from here to here. So let's see if you can do that. If you can't, that's okay. But if you do want to do that, pause the video and complete it. Now, before we do anything, please do remember, use the IDs of the points I said in order to do this. So for example, the ID of the tip of the thumb finger is 4, and the ID of the tip of the index finger is 8. Now, I'm giving you a few seconds to solve this, but if you need more time, pause the video. Okay, your time's up. Now that was pretty fast, but pause the video to get more time. Now let's solve this problem, right? So the first thing I said is I want a dot on the fourth on this point over here, or on the tip of the thumb finger. Now what can I do, guys? Well, the first thing we want to do is we want to write an if condition that checks if our ID equal to 4. Now, if our ID is equal to 4, that means the for loop is in the iteration, is in the third iteration, where it's basically getting the x and y values of the tip of the thumb. Right, actually it's in the fourth iteration that's getting the values of the tip of the thumb. Because in the 0th iteration, it would go over here. In the first iteration, it would go over here. In the second iteration, it would find these values. Third iteration, these values. And fourth iteration, these values. Since we want to only get the x and y values of the fourth iteration, we can put it over here. Now, the next thing we want to do, guys, is we want to get the x and y values so we can store them later on and use them later on, because when it goes to this next iteration, the x and y values of the thumb are not going to be stored, right? So we want to store those because later on, when we go on to the index finger, we want to draw a line from the index finger to the thumb, which will need 2 points. So what we can do is we can say thumb x and thumb y equal to cx and cy. Now, the next thing we can do is we can draw a line between, we can draw basically a blue dot in those locations. So we can say cv2.circle frame tx ty, because we just stored those values. And then last but not least, we can say, we can give it a radius of 6, a color of blue, so that would be 25500, and finally cv2.filled. So let's do that. Okay, now that we have that done, let's run my program real quick. Actually, let's do the next part too, and then we'll run our program. Actually, it runs, so I might not show you. So now, as you can see, voila. You can see it's actually on the finger. Now, if you want the blue dot to be on top of the thumb, then what I recommend you doing is writing this if condition after you draw the hand landmarks. And actually, so yeah, after you do that, you can draw it, which will make it come on top of the green red circles that MediaPipe is already drawn. Now that we have wrote some code to tell the computer what to do when it's finding the x and y positions of the tip of the thumb, let's also write some code that tells the computer what to do when finding the positions of the tip of the index finger of your hand. So now, first of all, we say if ID equal to, and if we tab back, you can see the ID of the tip of the index finger is 8. So over here we can say 8. And now, when the ID of the tip of the index finger is 8, we want to do two things. First of all, we want to draw a circle. And remember, when it's on the 8th iteration, we don't have to store these variables anymore, because the location of the x and y location of the tip of the index finger will already be stored in the cx and cy variable. So we don't have to do that. The reason we stored the tx and ty variable, the thumb's x and y location in separate variables, is because by the time we have to use those variables, by the time we want to use those values, they'll be erased in the cx and cy variable, because when it comes on to the next iteration, which would be 5, in the cx and cy variable, it would store the location of this value. So that's why we don't do that. Now we can say cv2.circle frame, and then again cx cy. And actually what we can do is we can basically get this code and paste it over here, with an exception of this being cx and this being cy. And then the last thing we want to do is we want to draw a line from the tip of the thumb finger to the tip of the index finger. In order to do that, we can say cv2.line frame from point 1, which is cx and cy, to point to the tip of the thumb finger, which we stored in tx and ty. Then we write down the color. So yeah, capital T, capital Y. And then we write down the color, which, yeah, let's do blue. Yeah, let's do blue. 2550255. And then the thickness we can write as 5, actually 6. Okay, let's do 5. And the line type is none. So now that we have that down. So actually, before we move on, let's actually change the line type to CV2.dotted. Okay, never mind. So we set our line type as none, and now we can write our program. So as you can see, you'll be able to see, there it is. And actually, what we can do is let's actually so what we can do is we can change this to 0. And now, instead of putting the mp.draw landmarks inside this for loop, we can bring it outside of this for loop. Because these mp.draw hand landmarks, this basically function doesn't need these x and y variables. It just needs the hand lm. So why repeat it so many times? Why not just draw it at the end of the process? Or instead, the beginning of the process. So if you want, you can put it there, but I'm just moving it. So as you can see, we have a straight line connecting the tip of the thumb finger to the tip of the index finger, and it works on both. Fingers. So you can see I can kind of cross them. That looks pretty cool. And a challenge for you is to connect all the tips of this finger to kind of create like a scale pattern, a webbing. So that will be a pretty challenging thing, and it'll take a lot of time because you have to hard code in a lot of stuff. But I know you can do it, and you can actually use a for loop to make this process a whole lot easier. And we'll discuss how to solve that in a future video. But as you can see, that's how you utilize fingers, or that's how you utilize points on your hand in order to do these cool stuff. And we'll do cooler stuff like adjusting the volume of the computer using your hand gestures, and many more cool stuff that will be coming. So make sure to comment down any questions you have or any recommendations you have, and if you do have any cool projects that you'd like to show me, then please do link out videos to those projects or send them to the email that I sent down, so I can watch those cool projects. So that's basically all we're going to do in this video. And thank you for watching. I hope you learned something new. So if you like this video, please do like, share, and subscribe it. It would mean the world to me. And again, thank you for watching. Have a nice day. Bye-bye.